guys, from the security point of view, is it good that VM1 is able to see the traffic associated with the other virtual machines as well? It is not good from the perspective of security. Okay, VM1 should be able to see only the traffic which is intended for it. It should not be able to see the traffic or observe the traffic which is not intended for. So here comes promiscuous mode. If you set the promiscuous mode to reject, this is the default setting. So what promiscuous mode will do is that it will prevent the virtual machine's network adapters from observing the traffic which is not intended for. That means respective virtual machines will observe the traffic which is related to them. That's it. They'll not be able to observe the traffic which is not related for them. So that's the reason why promiscuous mode by default setting is to be reject. If you enable this policy, that means if you change the promiscuous mode from default to accept, then what will happen is that the virtual switch will not prevent virtual machine's network adapters from observing the traffic which is not intended for. That means every virtual machine's network adapter will be able to observe the traffic which is not intended for it, and that is a security vulnerability. And if you set the promiscuous mode to accept, then most probably if there is an attack point, then maybe your virtual machines are prone to attacks. So better to keep this policy default, which is at reject. However, sometimes there might be a requirement for you to enable this policy. That means change the promiscuous mode from default reject to accept. When you have to change it, I'll explain that in a moment. Now coming to the next two policies, MAC address changes and force transmit. Now these two things are related to the same component, that is the MAC address of the virtual machine. Your virtual machine has virtual NIC and it has MAC address. Okay, and these two things are related to the same component, MAC address. First, we try to understand MAC address changes is related to incoming traffic and force transmit is related to outgoing traffic. Now, guys, by default, MAC address changes and force transmit are set to be at accept. Okay. Now, what is this? Is that certain guest operating systems, modern guest operating systems, has the functionality to change the MAC address. Certain guest operating system features allow administrators to change the MAC addresses. So MAC address changes, default setting is accepted. That means even if you change the guest operating system MAC address, your incoming traffic will not be blocked if you set the policy to accept. Suppose if you set the policy to reject, and when the guest operating system tries to change the MAC address, then the incoming traffics are blocked. That means it stops receiving frames. That means incoming traffic is blocked. In the same way, force transmit is related to outgoing traffic. The default setting is accept. If the guest operating system is changing the MAC address, your packets are not being dropped. If you set it to reject, then if the operating system tries to change the MAC address, then force transmits will block, will drop the frames when the guest operating system is sending if the MAC address is changed. So these are the three policies: promiscuous mode default reject, MAC address changes default accept, and force transmit default accept. However, sometimes you may change the promiscuous mode from reject to accept when you have to do it. For example, you are running a monitoring tool inside your virtual machine. Guys, monitoring tool functions on a basic concept that they observe the traffic in your network. Because of their observing the traffic, they are able to monitor it. So for observing the traffic in your network, promiscuous mode should be at accept. Then only that virtual machine will be able to observe the traffic. So if that's the scenario, then the best way is that whatever the policies I set on virtual switch will also get propagated to the port groups. If you see this VM network is a port group, we click on edit, you find the same policies. Okay. So whatever the policies I apply on a switch will get propagated to port groups. Suppose if there is any requirement for you to enable this promiscuous mode because one of the virtual machine is having a monitoring tool, then you need to enable this promiscuous mode on the port group rather than on the switch. If you enable this on a port group, then only the virtual machine which is connected to it will get that promiscuous mode accept. The remaining will get rejected. So maybe you have to create a separate port group with the name SNMP or the name of the monitoring tool and get your monitoring tool virtual machine connected to that port group and go to that port group, click on edit, go to the security policy. Here it is rejected, right, by default. So change it to accept. So what will happen? On the entire switch, the promiscuous mode is rejected, but for this virtual machine, it is accepted. So only this virtual machine can observe the traffic because it has to monitor. So this is how we have to use promiscuous mode in specific scenarios like if you are running a monitoring tool. Okay. So this is about your security policy. The next policy we are going to discuss is traffic shaping policy. However, this policy is said to be a disabled. Why? Because nowadays our hosts are having 10 Gbps cards. Even if you have 1 Gbps cards, we are using multiple 1 Gbps cards to handle the bandwidth in a more better way. However, this policy is used to control the bandwidth, basically, virtual machines network bandwidth. And this policy can control only the outgoing traffic guide. However, there are three, settings here. The first one is average bandwidth. Average bandwidth will be calculated in kilobits per second. Now, what is average bandwidth? The allowed average load. Fine. This is the average load which is allowed. And the peak bandwidth is also calculated in kilobits per second. Now, peak bandwidth is the amount of bandwidth which virtual machine can handle without dropping the packets. And the burst size, now this is calculated in kilobytes. The burst size, the maximum amount of data included in a burst. So this would be calculated in kilobytes. However, 99% cases there is no requirement for you to use this policy traffic shaping because we are using high bandwidth NIC cards, and those NIC cards can handle enough bandwidth. Those NIC cards has enough bandwidth so that all the virtual machines can communicate through that NIC card, the physical adapter. Then the third policy here is NIC teaming policy. Now, what is NIC teaming? Guys, on my virtual switch, I have only one NIC card here. However, I can add another NIC card. So two NIC cards can be teamed. Why do we team that NIC cards, the physical adapters? The first thing, to load balance. Second, as a failover, if one adapter goes down, I have other adapter to take care to handle the traffic. So here there are policies. Okay. Now in NIC teaming policy, if you keenly observe, the first one is load balancing method policy. In NIC teaming, you find load balancing method, network failover detection, notify switches, and failback. We'll try to understand all of these one after the other. First, we'll try to understand the load balancing methods. The load balancing methods are, the first one, originating virtual port ID. What is this originating virtual port ID? My virtual machines are connected to virtual ports. Okay. Now these virtual ports has IDs. So how your virtual switch is going to load balance is based on originating virtual port ID. What is the meaning of it? Is that the physical NIC card is determined by the port ID to which virtual machine is connected. If you use this policy or this method of load balancing, it is the fastest and the simplest method, and this is the default setting, and for almost all the workloads this setting works perfectly fine. However, you can also use other method which is based on source MAC hash. Here source is the virtual machine's NIC card, and the physical adapter which is used would be based on the virtual NIC's MAC address. Now it has low overhead on VM kernel, but however this policy has a problem that if you use this policy, maybe VM kernel will not be able to distribute the traffic evenly across the physical adapters. Then the third method involved is IP hash. So IP address. So here the physical adapter chosen based on the packet source and destination IP. Now this has high overhead, and however, when compared to source MAC hash, it will be able to distribute the traffic better. However, if you want to use IP hash, then your NIC card should support 8802.380 standard. Okay, this is a standard, guys, networking standard. If your NIC card supports this standard, then you can use this IP hash. If not, the originating virtual port ID would would do the best thing. Why? Because it is the fastest and the simplest load balancing method. Okay, so we can go with that policy. So apart from that, you have this node network failure detection. Now here we are detecting the physical network failure. Okay, and who is detecting it? VM kernel is detecting it. And how it is detecting? It is detecting it using the physical adapter connected to it. Now there are two methods how network failure is detected by VM kernel. The first one is link status only, which is the default thing. And using link status only, what type of network failures will VM kernel be able to detect? The first, using link status, VM kernel will be able to detect any network cable unplugs. For
Mujib,
example, yes,
can you explain the techniques again? I didn't understand. The
which techniques?
yeah, like the load balancing and these four policy
Guys,
exceptions.
load balancing methods. Now here, guys, here it is, load balancing is only related to outgoing traffic. Okay, so what are the traffic which is coming from the virtual machines is load balanced across two NACs or three NACs, whatever the NACs you have. Now the first method is originating virtual port ID. Means that NIC card is connected to the virtual port on the virtual switch, and that port has an ID. Now your virtual switch is going to determine the physical adapter based on the virtual port ID to which virtual machine is connected. So this is the fastest and the simplest method, and based on it, it will evenly distribute the traffic between multiple NIC cards and it will send the traffic out. This is the first method. Second method would be based on the MAC address. The NIC card is the physical adapter is chosen based on the virtual machine's MAC address. Now, if you choose this policy, then VM kernel will not be able to distribute the traffic evenly across multiple or across physical adapters. And the third option is based on IP address. So here the physical adapter is chosen based on the source and the destination IP addresses. Okay, and here VM kernel will be able to distribute the traffic evenly. However, if you want to use this policy, your physical adapters should support the standard 8802.380. There are different load balancing methods. However, the default method is based on originating virtual port ID, and this is the best way. And almost 99% of the workloads can be managed using originating virtual port ID. Okay. Normally, I haven't seen any requirement specifically where there is a requirement for me to change the load balancing method. The best method is originating virtual port ID. We can go with the originating virtual port ID, which is the default setting. Right? Now then comes the network failure detection. Now here, try to understand, we are trying to find out the physical network failure. We are not going to find out the virtual network. Here my virtual switch is finding out is there any physical network failure. Okay. So here VM kernel can find out that failures by two methods. One is link status only and the other one is beacon probing. If VM kernel is finding out the network failures by using link status only, what type of network failures VM kernel will be able to identify. Suppose there are network cables which are unplugged. We can identify that failures. It will show you network cable is unplugged. Okay. Second, if your physical switch is down because of power failure, then or due to some reason if your physical switch is down, then you can also find out that failure that physical switch is down. So this is the first option of link status only, And the second option here is beacon probing. Now, if you use beacon probing, then VM kernel can identify the network failures, whatever link status only can identify. Plus, it can also identify the configuration mismatch. For example, there is a wrong VLAN configuration has been done on the physical switch. So your VM kernel can identify that wrong VLAN configurations as well. As well as it can also identify the ports which are blocked by spanning tree protocol. So beacon probing will identify all the network failures with link status only can identify, plus it can also identify configuration mismatches like wrong VLAN configuration and the ports which are blocked by spanning tree protocol. For almost all the workloads, we can use link status only. However, suppose there are any important virtual machines running on your connected to your virtual switch, and you want even wrong VLAN configurations to be identified, then you can go with beacon probing as well. Fine. Then comes the fourth policy here, or the third policy, which is notifying switches. Now, which switches are being notified here? The physical switches are being notified. If you say yes, if you say no, physical switches will not be notified. Now, what are we notifying? And when are we notifying and what are we notifying? Guys, whenever a virtual NIC is connected to virtual switch, whenever a virtual NIC of the virtual machine is connected to virtual switch, then the physical switches are notified. But what are we notifying basically? We are notifying the MAC address of my virtual machine. Okay, this is the first thing what we are notifying. Second, in load balancing and failover, suppose I have two NIC cards, one of the NIC card has failed, then the traffic associated with virtual machines has to get rerouted from other physical adapter. So when failover occurs and when the switch is sending the traffic from other physical adapter, that changes, that is also notified to the physical switches. So if you see this, physical switches are notified by VM kernel when a virtual NIC is connected to virtual switch, and when failover event causes virtual NIC's traffic to be rerouted to a different physical adapter. So these two informations are being notified to your physical switches. However, we should not use notified switches policy as yes. Suppose if you have configured Microsoft Network Load Balancing on your virtual machines with unicast mode. Guys, on our virtual machines, if you have configured Microsoft Network Load Balancing, there is a concept in Microsoft Network Load Balancing, and you can configure it with unicast mode and multicast mode. Suppose if you have configured MSNLB, Microsoft Network Load Balancing with unicast mode, then you should not use this policy, notify switches as yes. If that's the case, you need to mention notify switches no. Now then the final setting here, which is failback. Failback, yes or a no. What is failback? Suppose I have two physical adapters connected. One is active, the other one is standby. Now, when the active adapter is down, then immediately the standby adapter will become active. And here, if you mention the policy failback yes, then after 15 minutes, let us say the original adapter came back. Then the original adapter will become active, and the standby which became active will become standby. If you say failback yes. If you say failback no, then when the original adapter is back up and running, it will continue to be as standby, and the standby which became active will continue to be as active. So that is the meaning of failback. To say yes, failed physical adapter is active whenever it's up. If you say no, failed adapter is inactive even after it's up. This is failback. So these are all policies available on your switch. Most probably, there is no need for you to change these policies. However, specifically when it comes to promiscuous mode, there might be certain reasons where you need to change this policy to active. I told you that if you are running a monitoring tool, then you need to change this policy from reject to accept. And suppose if you don't want this functionality of your guest operating systems changing the MAC addresses, then you can set this policy to reject. Then whenever the operating system tries to change the MAC address, the incoming and outgoing traffic should be blocked. Okay. So these are the policies on your virtual switch. 99.99% you can go with the default. However, if there is any requirement, you can change this policy. And these policies are also important when you are migrating virtual machines from one host to another host. That means vMotion. Guys, I discussed the prerequisites that during vMotion, stating that the VM network port group labelings and settings should be identical. Suppose label is the same, but if any of the settings are different, then vMotion will not occur. So during vMotions, if there are no identical settings, you may come across problems. Then you need to go and find out that what is the setting which is missing, which is stopping my migrations. So these settings are also important for migrations, okay, in vMotion as well. So this was about your vSphere standard switch policies. Okay. Now let us see another virtual switch in vSphere infrastructure, which is called as vSphere distributed switch. Now this switch, you can use this switch only if you have Enterprise Plus licensing, guys. You cannot use this switch if you have Enterprise licensing. It is possible only with the highest licensing, which is Enterprise Plus licensing. Now why this switch is used, vSphere distributed switch? Now this switch will provide centralized networking in your infrastructure. Using this single switch, vSphere distributed switch, you'll be able to manage the entire networking of your vSphere infrastructure. Okay. However, keep this in mind that it is possible only with Enterprise Plus licensing. If you have Enterprise Plus, then you can create vSphere distributed switch and use it. Again, vSphere distributed switch is configured and managed at vCenter. Okay. Now this switch functions as a single switch, but it is distributed across multiple ESXi hosts. So let us see vSphere distributed switch. Guys, vSphere distributed switch configured and managed at vCenter level. This switch functions as a single switch, but it is distributed across multiple ESXi hosts. That means associated with multiple ESXi hosts. Now this particular figure, what you're seeing, it's quite complicated. Let me make it simple. Now let us say I have 3 ESXi hosts in my infrastructure. This is my first ESXi host. This is my second ESXi host. And this is my third ESXi host. We know that every ESXi host has at least one switch. That basic switch is called as vSphere standard switch, and it has left-hand side connections and right-hand side connections in this way. On the left-hand side, you have port groups, and on the right-hand side, you have uplinks. Left-hand side port groups, right-hand side uplinks. Now, let us say this is my ESXi 1. This is 2. And this is 3. Okay, and let us say I have virtual machines on each ESXi host. Let's say I have virtual machines 1, 2, and 3 on ESXi 1. 4, 5, 6 on ESXi 2. 7, 8, and 9 on ESXi 3. Now they are all connected to my standard switches respectively. Now, I am creating a vSphere distributed switch. vSphere distributed switch functions as a single switch, but it is distributed across multiple ESXi ports. vSphere distributed switch is similar to your standard switch. Okay, it also has left-hand side connections. On the left-hand side, you have a port group created, and this port group is called as DV port group. And the right-hand side, you have uplink ports. On the right-hand side, I have uplink ports. What are uplink ports? That means there are ports available so that the uplinks, that means the physical adapters from the ESXi host, can be connected. On the right-hand side, I have uplink ports. Now, these uplink ports are for host. It is very important, guys. Don't get confused with this concept of uplink ports per host. What is the meaning of it is that whatever the uplinks are available, it is per host. Let us say that I have created a vSphere distributed switch with 2 uplink ports. What would be the meaning of it? If I say that I have created a vSphere distributed switch with 2 uplink ports, what would be the meaning of it?
We are connected to hosts. We are going to.
No, Prabhakar. It is not the meaning that we are connecting 2 hosts, 2 uplink ports per host. That means 2 uplinks from each host can be connected. That is the meaning of it. Yeah. Did you get the concept? Yes. Keenly observe. Uplink ports per host. Okay. If I say that I have created a distributed switch with 2 uplink ports, now those 2 uplink ports are per host. That means from every host I can get connected 2 uplinks. That means 2 physical adapters from each host can be connected. Yeah. Clear, guys? The uplink ports are per host. Try to understand. Per host. If I say 2 uplinks ports, that means 2 uplink ports per host. How many hosts I have right now? 3. Right? If I say that there are 2 uplink ports, that means 2 uplink ports per host. That means from every ESXi host, I'll be able to get connected 2 physical adapters. That means 2 uplinks from each host. Clear with the concept? That means total how many ports?
6.
6. If there are 4 hosts, then 8. In that way. So always uplink ports are per host. Keep that in mind. Don't get confused. Clear? Clear with the concept? Now, this virtual switch functions as a single switch. Yep.
Actually, according to this uplink port, we should have physical port also. Suppose if we have 2 uplink ports, means we should have 2 physical ports. Physical adapters.
2 physical adapters can be connected.
Adapters.
2 physical adapters can be connected from each host. Clear?
Oh, okay. Thank you.
Fine. Now guys, this is appearing as a single switch. It functions as a single switch, but this switch is distributed across multiple ESXi hosts. Okay. Now, I can migrate the virtual machines which are connected to my standard switch to get connected to my distributed switch. Now, let us say that all the virtual machines on 1, 2, and 3 on ESXi 1, 4, 5, 6 on ESXi 2, 7, 8, and 9 on ESXi 3, I'll migrate them and I'll get connected to my distributed switch to my DV port group. Okay, so let us say virtual machine number 1, 2, 3, 4, 5, 6, 7, 8, and 9. All my virtual machines from VM1 to VM9 are now connected to my DV port group on my distributed switch. So VM1 till here, this is VM9. Okay. Now, guys, this is a virtual switch. Distributed switch is also a virtual switch. without an uplink, that means without a physical adapter connected to it, my virtual machines will not be able to communicate with my physical network, right? So that means I need to connect one uplink. So let us say I have connected one uplink. This is my physical adapter. Okay. Physical NIC, which is my uplink. Now I'll ask you a question, guys. I have one physical adapter connected to my distributed switch, and I have virtual machines number 1 till 9 connected to my DV port group on my distributed switch. A question: will all these virtual machines from VM1 till VM9, will they be able to communicate with this uplink? Can all the virtual machines from VM1 till VM9 use this physical adapter which is connected as its uplink and communicate with the physical network?
Yes.
Can they communicate?
They are all in the same network, they can communicate.
Okay. Anything else? Anything else, guys?
Zoning required?
No, no concept of zoning here. My question is pretty simple. I have one uplink connected to my distributed switch, okay, and I have all my virtual machines VM1 till VM9, okay, connected to my DV port group. My question is whether VM1 till VM9 will they be able to communicate with the physical network using the uplink which is connected. Absolutely right. Rupesh is absolutely right. No, guys, all these virtual machines will not be able to communicate with the same uplink. Why? Because uplinks are per host. Now we need to understand where is this uplink coming from. Suppose this uplink is coming from ESXi 1. Are you able to understand, guys? If this uplink is from ESXi 1, then which are the virtual machines will be able to communicate?
2, 3.
VM1, 2, and 3, right? Clear? VM1, 2, and 3 will be able to communicate with this uplink. Why? Because this uplink is from ESXi 1. What about the virtual machines 4, 5, 6, 7, 8, and 9? They will not be able to communicate. Why? Because there is no uplink from their respective ESXi hosts. Clear with the concept? So that means if your ESXi host has to use distributed switch, then host has to give at least one uplink to it. If there is no uplink from the ESXi host, then the virtual machines will not be able to communicate. So that means I need to have at least one uplink from every ESXi host. So another uplink, let us say, from ESXi 2 and the third uplink from ESXi 3. Now in this way, I have uplinks from all the ESXi hosts. Let us say this is the uplink from ESXi 2 and this is the uplink from ESXi 3. Now the virtual machines VM1, 2, and 3 will be communicating with its uplink ESXi 1, 4, 5, 6 with its uplink, 6, 7, 8, and 9 with its uplink. Okay. So here, try to understand that though this switch is appearing as a single switch, functions as a single switch, but this is distributed across multiple ESXi hosts. That's the reason why when you see the switch from vCenter perspective, it appears as one big switch. But you see, when you see the switch from ESXi 1, you see only this part of it. When you see this vSphere distributed switch from ESXi 2, you only see this part of it. And when you see this virtual vSphere distributed switch from ESXi 3, you only see this part of it. Though it appears as a single switch, it functions as a single switch, but this switch is distributed across multiple ESXi hosts. You have the concept, guys? Any confusion? Clear? Yeah. The biggest advantage of having this switch is that, guys, if you don't have this switch, then if you want to configure networking on 100 hosts, then you need to go to each and every host, go to the networking tab, go to that, let's say, configuration tab, go to the networking, and do the configuration changes on that respective networking. If there are 100 hosts or 20 hosts or 30 hosts, it is very difficult for you to go on each and every host and do the configuration changes. If you have the vSphere distributed switch, with a single view, with a single instance, I'll be able to manage my entire vSphere networking. vSphere distributed switch. Yeah.
How
It
do we
is
check? How do we check that uplink ports, and how do we know that we need to manually assign that, or
Yes,
it
you need to
works?
manually assign. You need to manually assign. In a moment, I'm going to show you the practical concept of it, how to create the vSphere distributed switch, how to add hosts to it, how to add uplinks to it, how to migrate the virtual machines which are connected to your standard switch to the DV port group. You can also migrate the virtual machines from distributed switch to the standard switch. We are going to see all these things practically in a moment. But are you clear with the concepts?
Yeah, thanks.
All right, guys. Most of the way, like
So here,
distributed switch. Yep.
DV port group is equivalent to like VM network?
Okay, good question, Hari. Now here, DV port group is equivalent to VM network port group. Yes, as well as a no. Why yes as well as a no here is because yes, DV port group is equivalent to VM network port group. Why? Because virtual machines will get connected to it. No. Why? Because VM kernel ports can also get connected to the same port group, DV port group. Clear? Here in standard switch, VM kernel ports are connected differently. They are not connected to VM network port group. But here in distributed switch, your VM kernel ports can also be connected to the same DV port group. Yeah?
Okay. So what is the purpose of like combining both of them? How it's different from VM network group? Like is there any
See here,
special feature?
in standard switch, there is a separate port group for virtual machines and separate port groups for VM kernel ports. Okay? But here, the same port group can be used by both. Fine. Yeah, or you can create a separate port group and maybe you can dedicate it only for VM kernels. You can do that as well. Okay? You can dedicate separate DV port group and dedicate only for VM kernel ports. That is also possible. But however, I can connect virtual machines as well as VM kernel ports to the same DV port group if I want to. But that is not possible on standard switch. Yeah? And let me compare the differences here. Guys, both are switches, both are virtual switches, okay? Both functions the same way. However, distributed switch has some extra, networking features like port mirroring concept, okay? And it supports private VLAN concept, okay? Whereas standard switch doesn't support private VLAN, whereas distributed switch supports private VLAN and port mirroring. All right? And when it comes to policies, just now we have seen the policies. Policies are also absolutely the same, okay? However, this distributed switch can control inbound traffic as well as outbound traffic, whereas standard switch can control only outgoing traffic. Okay, when it comes to traffic shaping, the standard switch can control only outgoing traffic, whereas the distributed switch can control incoming and outgoing traffic as well. All right. So now let us see practically how to create a distributed switch. Okay. And again, keep this in mind, we can create a distributed switch only on vCenter server. That means configuration and management only on vCenter server. So let me get connected to my vCenter server.
So distributed switch is per cluster?
Data center.
Per data center.
Yeah.
Okay, so it same distributed switch we can use for different clusters, right?
Yes, you can include that. Not an issue. Fine.
Actually, yesterday while doing practice, I haven't seen that update manager tab in my vCenter server, the home page. Then I try to start the services from 2008 server where I installed the download manager.
Okay.
Then I'm getting a error like that. You cannot start the services on local system like that. I'm getting a error. What is that?
On your machine,
Yeah,
okay, whether you have logged in as a domain administrator or a local administrator there.
a domain administrator.
Okay, let me check out. Okay, check out.
Yeah, okay. Even I think in 205 also it's not started. That one it was not there.
Okay, check out. All right. Let my vCenter get powered on. Has to start the services as well. Let me discuss a few more points on vSphere distributed switch. Okay, now guys, as on a standard switch, our port groups can be configured with VLANs. Okay, our port groups can act as access ports, can act as I can assign a VLAN ID. Those port groups can act as access, trunk ports, so on and so forth. In the same way, on the distributed switch as well, the port groups can be assigned with VLANs. Okay, the first option is VLAN set type to none. That means no VLAN has been configured. If you don't configure any VLAN, then that port group can handle only the untagged traffic. Fine. However, the physical adapters which are connected to that switch. Okay, for example, here, this is my net switch, right? Now this is the physical adapter, and this will go and get connected to a physical switch, right? So if you are configuring on the port group as VLAN none, then the physical adapter which is connected to the port on the physical switch that port has to be configured as access ports. That is what I have mentioned here. If VLAN type set to none, the TV port group will receive only untagged traffic. That means there is no VLAN configured. In this case, the uplinks must connect to physical switch ports configured as access ports. That means the ports where your physical adapters are connected on the physical switch, that port should be configured as access port. Okay. Now, if you set the VLAN type set to VLAN ID, suppose I have configured VLAN 10. Okay. Then TV port group will be able to receive the traffic associated with VLAN 10, and the uplinks which are connected to the physical switch, that port should be configured as trunk port. Now, I can also configure my DV port group as VLAN trunking. If I configure it as VLAN trunking, then I need to mention the range of VLANs which are allowed. If that's the case, then your uplinks which are connected to the physical switch, those ports should also be configured as VLAN trunks. Okay. Then this DV port group has the feature of private VLANs. What is a private VLAN? Private VLAN is further segregation of ports, further isolation of ports within a VLAN. So VLAN within a VLAN is called as private VLAN. So you can configure private VLANs as well. Suppose if you want to configure it a private VLAN, then you need to specify the private VLAN entry there. However, guys, keep this in mind. Whatever the VLANs we configure on virtual switch, first we need to configure VLANs on our physical network. Then only we configure our VLANs on our virtual network. If there are no VLANs configured on the physical network, then we do not configure VLANs on our virtual network. These settings are common for both the standard switches and the distributed switches. However, the distributed switch will support private VLANs and certain advanced networking concepts like port mirroring. Other than that, the functionality wise, both the switches are absolutely the same. And we know that two virtual switches cannot be connected together in the same way. The two distributed switches will not be able to connect it among multiple switches. So always keep this in mind in virtual networking. We cannot connect two virtual switches together internally. So functional wise, standard switch and the virtual switch, standard switch and the distributed switch are the same. However, distributed switch provides ease of administration, ease of networking. With a single switch, I'll be able to manage my entire virtual infrastructure, entire vSphere infrastructure. So check out what's happening.
Yeah, Mujib, I have one doubt.
Yeah.
Yeah, within a VM network, can we have multiple VLANs?
That means within a VM network port group?
Yes.
Yes, you need to mention the VLAN tags there.
Oh, okay.
Yes. You need to configure that port group as access port. The trunk port. Once you configure it as trunk port, you need to mention what are the VLAN tags it needs to handle. If you mention that, then it will be able to handle. Okay?
Okay. Thank you. I am getting also same error.
Usually, these settings should be automated delay, because they need to start one after the other. Usually, they start automatically. We need to wait for some time. Try to start forcibly, they'll give you an error. See, if you say that it's starting, it's taking time.
Actually, there's one server I was able to start, but update manager only I have problem. Even I waited. Wow.
Once these services are started, then we can start the update manager. Okay. Sometimes it gives an error. It's starting, still under starting. Automatically it will start. Why? Because it has been set to automatic delay start. Why? Because this service depends on these two services. Okay. So if vCenter inventory service and single sign-on service is not started, then this service will not be able to start. Why? Because they depend on those services. So that's the reason why they are by default set to be automatic delay. And vCenter service is up. I'll be able to act with control. Okay, first, guys, you can create vSphere distributed switch on vCenter server. However, you cannot create it from the inventory view, host and clusters. For that, you need to go to home, go and select inventory view networking. On networking, you need to select the data center where you want to create a distributed switch. Right click, and here you find the option which says new vSphere distributed switch. Okay. Here there are different versions of vSphere distributed switch starting from version 4 till 5.1. However, these switches are forward compatible, not backward compatible. Meaning, if I create a vSphere distributed switch version 5.1, then this will not be compatible with the older versions of ESXi or ESX. So if you have older versions of ESX or ESXi in your infrastructure, better you create the oldest version because it is forward compatible. However, the latest features will not be available on that particular switch. So I'm going with vSphere distributed switch 5.1. Click on next. Now this is the switch name. Already I have created one DV switch. Alright. Now this is another switch. That's the reason why it has given the name as DV switch 2. And here you find the number of uplink ports. 4. That means the maximum number of physical adapters per host. Uplink ports are always per host. If there are 4 uplink ports, that means from each host, 4 physical adapters can be connected. Okay. Next. Now here I can add the host to this physical distributed switch, add the host to distributed switch. If you want to add now, you can add 1.20 and 1.30. However, I don't want to add now. I'll show you how to add it later. Okay, so I'll say add later. Click on next. Okay, this is how the switch appears. It is going to create a DV port group automatically on the left hand side where your virtual machines can get connected. On the right hand side, you have uplink ports. Click on finish. Here, a new switch has been created, which is DV switch 2. You click on it, you find on the right hand side all the tabs associated with it. The most important tab is the configuration. This is the switch, how it appears. Okay, on the left hand side, you can get connected. You can connect your virtual machines. On the right hand side, you have uplinks. Right now, the switch is available, but I haven't added any host to it, so I need to go and add host. How to add host? You find the option which says add host here, or you can right click on this DV switch 2 and you find the option to add host. So I'm clicking on add host now. Now I can add 1.20, fine, and one uplink is required from every ESXi host, guys. So I have only two uplinks, VMNIC 0, which is being used by vSwitch 0, VMNIC 1, which is being used by DV switch. Fine, that means the first DV switch. So let me select VMNIC 2, all right, so that it will get disconnected from DV switch and it will get connected to my new DV switch 2. I'm adding 1.30 and I'm selecting VMNIC 1 as uplink. So I'll click on next. Here, these are the VM kernel ports available on my 1.20 and 1.30. Here it gives me an option to migrate these VM kernel ports from the standard switch to my distributed switch port groups. If you want to migrate this, you can migrate. If not, you can just leave it by default, do not migrate. Click on next. If you want to migrate a specific VM kernel port to distributed switch, then you need to select that VM kernel port which is being used for management, for example, and migrate it to DV port group 2.
Is this impactful? Migrating from standard to distributed switch is impactful or non-impactful?
I mean to say, will it impact?
Yeah. Yes. Impactful means does it require
Will it impact the
downtime?
production environment?
Yes, production environment.
Will it impact the production environment you're talking about?
Yes. Yes.
Yes, guys, for a little moment there would be a hitch. Okay, so whenever you are migrating, make sure that you migrate it in non-production. Like for example, maybe during the maintenance you migrate it. Fine.
Okay, so it is suggestible to migrate in maintenance window, like from standard
Yes.
to distributed switch.
Yeah, whenever you're not doing any task on that virtual machine, maybe you have shut down it or this kind of stuff, you can migrate it. Fine.
Oh, okay.
And you can also migrate the virtual machine networking as well. Okay, you can migrate all the virtual machines if you want to, or I'll show you how to migrate it later, how to migrate the virtual machines. I'm not selecting any virtual machines. Click on next. Now this is your virtual switch, and you have the uplink ports created so that the uplink from every host can be connected. Click on finish. Here, the host has been added.
Can you go to
Yep.
the previous screen?
What do you want to see?
Okay, so okay.
We got
Just to
This
host
is what
the
I'm
adapter
trying
to
to
each port. Okay.
see. The uplink port 1 means the first adapter is always connected to the uplink 1. No matter how many hosts, they are always connected to the uplink 1. The first NIC from 1.20, the first NIC from 1.30. The second NIC from 1.20 will be added to DV uplink 2. Third NIC will be added to DV uplink 3. Fourth NIC will be added to DV uplink 4. Clear?
Okay.
So I have uplinks available from every host right now. Okay. Now I can migrate virtual machines from one switch to another switch. Okay. Right click. You find the option migrate virtual machine networking. Now here I can include all virtual machine network adapters. Guys, virtual machines get connected to port groups. Here we will not be able to migrate the virtual machine based on host. but we can migrate the virtual machines based on port groups. For example, this is the source network. If I select DV port group, DV switch, whatever the virtual machines which are connected to DV port group, DV switch will get migrated to DV port group 2. If I select the port group production, then all the virtual machines which are connected to production or prod port group, whether this prod port group is available on ESXi1 or ESXi2, ESXi3, all the virtual machines from ESXi1, ESXi2, ESXi3 will get migrated to DV port group 2. Here, virtual machine network adapters always get connected to port groups, and here the migration is from port group to port group, and here it is not from host to host. We cannot select from host wise. We can select port group wise. However, in the next screen, let me say that all the virtual machines which are connected to DV switch, DV port group, I want to migrate to DV port group 2 on the DV switch 2. When I click on next here, in this screen, you will be able to see all the virtual machines. Now, if you want to select all the virtual machines, you can select, or specific virtual machines you want to select, you can select those specific virtual machines. Alright, so in this way, let me select all the virtual machines, click on next. Now here, there are total 73 virtual machines and 104 network adapters. All these virtual machines will get migrated to my DV switch 2 and that to DV port group 2. Click on finish. Now you can see this. Slowly the virtual machines will get migrated.
Jose, can I practice in my vCenter server?
Yes, absolutely. You can practice on your vCenter as well as on your virtual ESXi as well.
Okay, good. Actually, while adding one more port, it is giving some warning. This particular adapter is assigned to some other host.
Maybe you have only
from there.
No, maybe you have only one uplink there. Okay.
Yeah,
so
I have only one uplink.
So add another uplink. How you are going to add another uplink is that suppose your virtual ESXi. Who is this? Prabhakar?
Yes, Prabhakar.
Prabhakar. Now this is your ESXi, right?
Yes.
If I see, I think you have only one adapter available. Two adapters available. Okay. Fine.
Yeah, but
yeah, maybe you are using two switches there.
Only one.
Zero,
Actually, I am using only one.
Or maybe you have connected to the same switch, both uplinks.
Yes.
Yeah, that's what.
No,
that's the reason why it is giving me a
switches.
warning. Yeah, maybe different switches. Why? Because adapter is already connected to one switch. That's the reason why it will tell you that, okay, you want to remove there and connect it to this. If you say yes, then that uplink would be removed from that switch and get it connected to this switch. Okay.
Okay.
Why? Because I told you in the beginning itself that adapter cannot be shared with multiple switches.
Okay.
Fine. Suppose if you want to add another adapter, do one thing, click on add, select another adapter, click on next,
Okay.
and you can continue in this way. Clear?
Okay. Thank you,
Fine.
Mr.
You're welcome. See guys, slowly all these virtual machines are getting connected to my DV port group 2. Okay. Now, I told you that when I see my distributed switch from vCenter perspective, this is vCenter perspective, it appears as one big switch. But when I see it from the perspective of ESXi, I told you that I can see only this part of it, only the part associated with it, only this part of it. That means the virtual machines and the uplink associated with ESXi1. So let me show you that. Here I can see both the uplinks. Why? Because I am seeing from the perspective of vCenter. This is the view from vCenter. But when I see from ESXi, host and clusters, 1.20, go to vSphere distributed switch. Okay. Now here,
asking Mujib, where can we see that heartbeat, network heartbeat in DRS? In which view?
No, in HA you are talking.
Yeah.
See, network heartbeat is nothing but your, the management network port, the VM kernel port configured for management network.
No, I'm not talking about that one, but where can we see that whether the HA is functioning or not?
See,
The two
it is nothing but a ping,
aligned or
guys.
not?
It is nothing but a ping, okay, which sends. In the summary here you can see
Oh, cluster status.
cluster status. Here you can see the heartbeat. These are the two heartbeat data stores. Okay, network heartbeat, the VM kernel port configured for management network is going to send the heartbeats. Okay, every second there will be a heartbeat being exchanged between the masters and the slaves. Okay. Now, guys, individually, you can also migrate a single virtual machine from one port group to another port group. Okay, how you can do that? This is my DC Zoom. Okay, right now it is connected to my standard switch, vSphere standard switch, that to a port group called VM network. I want to migrate this to my TV port group. Right click, edit settings, network adapter, and here select the network label here. TV port group 2. Click on OK, and this virtual machine will get migrated there. Okay. Now, this is Zoom. This now it is on TV port group 2 on my distributed switch. Manually, you can also do it. See, this is Zoom is here. Okay, have you seen it? Manually you can do it, or you can migrate totally a group. Fine. Now I can also migrate virtual machines from group to a, and I right click this, I find the option migrate virtual machine networking, and if I select the source as DB port group 2 and the destination will get migrated to standard port groups. This is the advantage of distributed switch. From a single switch I will be able to manage my entire virtual networking, and it is ease of administration. So need not go to each and every ESXi host, go to the configuration tab, the networking, and do the configurations here. Rather than doing that, I would be in a single view on my vSphere distributed switch, and I can manage hosts, add a port groups, edit settings, everything from here. However, one thing you cannot do from this view, which is you cannot create a VM kernel port from vCenter perspective. If you want to create a VM kernel port, then you need to do it from the ESXi. Here, go to vSphere distributed switch, and here you find manage virtual adapters. If you click on manage virtual adapters, this is how you can create a VM kernel port and get it connected to your distributed switch. Okay, or you can migrate existing virtual adapters to your. When I say this virtual adapters, these are VM kernel adapters. Existing VM kernel adapters to your distributed switch. This job is done from within the ESXi. Other than this, everything can be managed from the distributed switch perspective from this configuration tab. Right? I think all the virtual machines got migrated. Fine. Now, if you see this port group, if I right click and click on edit settings, you find these policies, security policy, the promiscuous mode, MAC address changes, and post traffic. These are the same policies, guys. However, if you see this traffic policy, ingress means inbound, egress means outbound. So this is one difference. VLAN type, You can set the VLAN none, VLAN. You need to mention the VLAN ID. You set the VLAN trunking. You can mention the range of it. If it is a private VLAN, then you need to mention the private VLAN. Private VLAN is not configured. Okay. First, we need to configure the private VLAN, then we can go and configure it. So all the things are absolutely the same. However, there are few, new features in your distributed switch, like port mirroring, for example. We find here private VLAN, NetFlow, and port mirroring. So these are the concepts which are not available on your standard switch, but these concepts are available in your distributed switch. Now, I don't know whether you people are aware or not. Cisco is known for its switches and routers worldwide, right? Now, Cisco has developed a purely virtual switch for vSphere infrastructure, Cisco Nexus 1000V and Cisco Nexus 7000V. These are purely virtual switches, specifically designed for vSphere infrastructure, and these switches are distributed switches, similar to your vSphere distributed switch. And once you deploy that, the networking can be handled by your networking team. Why? Because those switches are virtual switches, but they can be managed as physical switches. Inbuilt, they have Internet Working Operating System on it. By using the command line, you can manage that virtual switch similar to that of the physical switch. Okay, and Cisco has also come up with a virtual router specifically for vSphere infrastructure. All these virtual routers and virtual switches run as virtual appliances. So nowadays, everything is becoming virtual, and in order to meet the virtual infrastructure, organizations and companies are developing virtual switches and virtual routers. And Cisco has developed virtual switches and virtual routers specifically for vSphere infrastructure. Alright guys, this is how we manage or create our distributed switch and add or post to it and add uplinks to it. Okay. Now you can migrate virtual machines from standard switch port groups to distributed switch port groups, from distributed switch port groups to manage standard switch port groups. Okay. Normally, you can do it while your virtual machine is running, but better to do it when your virtual machine is in power off state, so that you can avoid that hitch which comes in. Right? Recommended it. When you're doing certain maintenance tasks, do that particular task. Okay.
So
however,
how long is that hitch? Like, is that a couple of seconds?
It's pretty minute. Okay. Suppose you are running critical applications, then that minute hitch may affect. So better not to do it. Even if you do it, that minor hitch can be handled. Not an issue. Why? Because it's if you observe, maybe there will be a slight ping loss. There will not be data loss, but there might be a ping loss, most probably. But if you ask me, if you want to migrate things like that, then better to do it during the non-peak hours, or where there is no, you're doing certain maintenance tasks at that particular time, migrate it off, rather than doing it directly during the production. Okay. So this is how we manage and create our vSphere distributed switches. However, this is only available with Enterprise Plus licensing. Only large infrastructures use these switches. Why? Because there is a lot of networking involved and so many hosts involved into it. So that's the reason why this will come handy for administrators for managing the virtual networking from a centralized location. So from here, I can manage the entire virtual network. Okay. So this is how.
You said the Cisco Nexus 1000. Can we deploy it in other versions?
Like on which host you want to say?
Enterprise or standard,
yes,
or this basic something.
The basic part, no. Why? Because it requires this distributed switch licensing. I think it can be deployed only on Enterprise Plus.
Oh, okay. Even though we are going for Cisco, we can install it on Enterprise.
Enterprise Plus, yes.
Oh,
Yeah, because it requires a distributed switch. It is also a distributed switch basically.
So we can do labs for the distributed switches, right? Because all of ours are evolution version.
Yes, in the evaluation version, everything is available. No feature is blocked in the evaluation version. Every feature is available. Okay.
Oh.
So this is about our vSphere distributed switch, guys. Okay. And now I would like to take a small topic, which is RDM. Guys, you remember RDM? What is RDM?
remote desktop monitoring.
Raw device mapping, guys.
Yeah, sorry.
All right. Raw device mapping. You remember raw device mapping? What is raw device mapping?
Assigning LAN directly to a virtual machine.
Absolutely right, Hari. Assigning a physical LAN directly to a virtual machine. Now, how to do it? Okay. First, guys, your host should be able to access a LAN. Okay. First, the host should be able to access a LAN, and host should not use that LAN. What is the meaning of it? There should be LAN configured on SAN, and you need to give this LAN access to the ESXi host, but you should not format that LAN with BMFS. What is the meaning that ESXi host should not use that LAN? That means it should not be used by ESXi. It should not format that LAN with BMFS. It should be a raw LAN. That's it. Okay. So how we can configure it? On your SAN, create a LAN and give access to your ESXi host. For example, here. I configured one LAN. Who has given this? Let me remove that.
So if we have a Vmax or DMX or a NAS storage in our environment, right? So we have to add those servers here, like in dynamic discovery, the same way we
Yes.
did here.
Yes. All you need to mention is the IP address of that particular SAN server.
SAN.
Okay. Yes. The dynamic discovery, and if the LAN is exposed, you can see that LAN available to you. Okay.
Okay. So
I'll show you in a moment.
so it's going to be the server where those tools are installed, right?
What do you say?
Like for example, Vmax, it's just a storage box, but we have
Yes.
some ARM servers, other management servers. So those other management server addresses has to be added here. Right?
Yeah.
Okay.
Okay. Now here I have created a LAN on my 1.222. Okay. So let me add that host here. 10.0.1.222. And I have created just for testing purposes a 2 GB LAN. Okay. And I have named it as see, this is that LAN, guys. RDM test 1, and I want to assign this to my VC Zoom machine. Okay. So this is the LAN which is available. Click on close. Say yes. It will rescan. Once that LAN is available, now you need to go to the virtual machine to whom you want to assign this LAN. Let us say I want to assign this LAN to my VC Zoom machine. Okay. Go to that machine. Okay, it is on 1.30 now. I have to configure the LUN to 1.30 as well. I think it is already configured. Yeah, it is available. Fine. So let me go to VC Zoom. Right click, edit settings. Now here, click on add. You have to select the hard disk. Well, because we are adding a hard disk to my virtual machine. Click on next. Now you find this raw device mapping highlighted. Previously, when you created virtual machines and when you created a virtual hard disk, this raw device mapping was not highlighted. Did you observe this, guys? It was grayed out. Now why it is highlighted is because now my host is able to access a LUN and my host is not using that LUN. It is freely available. So when a LUN is available, then this raw device mapping option will get highlighted. If the LUN is not available on the host, then it will not be highlighted. So let me select raw device mapping. Click on next. Now here you find two LUNs, guys. Okay. I'll select the first LUN, which is 2 GB. Most probably fine. Click on next. And here, guys, when you assign a LUN to a virtual machine, then this LUN is accessible through a mapping file which is called as RDM, raw device mapping file. Now this mapping file usually has to be stored with the same virtual machine. Okay, this is recommended. So I am going with the same option. However, you can also store this RDM on a different data store. Alright, but the better is to store this LUN mapping file along with the virtual machine itself. Click on next. Now here, there are two compatibility modes of that LUN mapping. One is the physical mode. Then what will happen is that the virtual machine's guest operating system can access this hardware directly. However, if you go with physical mode, when you take a snapshot, then this physical LUN will not be a part of that snapshot. That means you cannot take snapshot of this physical LUN. If you go with the virtual mode, then this appears as a virtual hard disk, and when you take a snapshot, then this LUN will be a part of that particular snapshot. So there are two modes. If you go with the physical mode, you cannot take a snapshot of this LUN. If you go with the virtual mode, you can take a snapshot of this LUN. That's the only difference here. I'm going with the physical mode. Click on next. The SCSI ID 01. Next. This is the entire summary of it. Click on finish. Now here, they're saying new hard disk adding, and it's saying that map raw LUN. Click on OK. Now a LUN is added to the virtual machine, but how you can see that LUN? Guys, it appears as a local hard disk to your operating system. So open the console. And we go into the disk management of this virtual machine. That LUN would appear as a hard disk to it. You see this 2 GB LUN? It is appearing as a hard disk because I told you when LUN is presented to your machines, to your operating system will consider as a local hard disk, and now it is not formatted. I can format that if I want to, okay, and use it. Okay, and maybe I can install any application on it, and this application will be on my LUN, alright, so that I can get better performance for this application. Alright, so this is how we configure RDM, guys. It's pretty simple, two configurations. The first thing, there should be LUN available to your ESXi host, and your ESXi host should not use the LUN. Then to whichever the virtual machine you want to assign this LUN, you have to go to the virtual machine, go to edit settings and click on add hardware, select the hard disk and select raw device mapping, and then you assign this LUN to this virtual machine, and this LUN will get added to it, and it appears as a local hard disk in your disk management. You can format that, you can install any application or any data on it, so that you get better performance. So this is all about RDM. It's very simple. Yeah. Clear, guys?
Sorry.
All right, guys. I'm done with today's session. Okay. Tomorrow we are going to continue with most important topics: ESXi architecture and troubleshooting. Guys, don't miss this class because we need to understand ESXi architecture as well as I'm going to deal with troubleshooting real-time scenarios.
Mujib,
Yes.
regarding the lab, right? So 8:30 is the earliest time you can power on the servers in the morning.
In the morning,
Yeah, because
8:30 Indian Standard Time.
yeah, because it is 10 p.m. for me, and if I do the lab for 1 hour, and it's very hard for me to wake up at 5 o'clock and catch up the again office, and so
Okay, fine, guys. From fine tomorrow, tomorrow and day after tomorrow, yes, I'll power on the servers at 8:30 morning Indian Standard Time.
is it possible to do before that? That what I mean.
Before 8:30 a.m.
Yeah, yes.
Before 8:30 a.m. it would be difficult.
7 o'clock something.
7 o'clock would be a difficult task.
Okay, because both timings are conflicting with my class. The same.
Okay. Fine. Like, what about 2 hours before the theory? Is it okay?
Yeah, that's too early.
What would be the timing for you then? 1:30 p.m. Indian Standard Time.
Yeah, currently it's 7 a.m. So my class started 5:30 a.m. So if it's a 2
Okay, so
hours,
it will be
then
odd for you.
yeah.
So can't you
3:30.
continue after the class?
Yeah, I'm sorry. My office starts at 8:38.
Oh.
Yeah. Well, the
Okay,
only thing
fine.
that looks like familiar to me is 1 hour before the morning, something like that.
Okay, fine. Let me check out what can be done regarding that.
Okay.
Okay, fine.
And can you consider the how about powering on the VMs a lab on the weekends, like little bit more time for practice?
Guys, usually Sunday Zoom is closed. Okay.
Okay.
The last Sunday, you people requested it, so I have to. I came all the way and I powered on the servers and I was associated with you guys. Fine. Sunday would be a difficult day for us. But the only day we get time is Sunday. So,
How about Saturday for extra time? Is it possible?
fine, guys. Guys, I told you, morning 7:30. I'll look into it. If we're able to power on the servers at morning 7:30 Indian Standard Time, it will be powered on. And those will be powered on till 11 a.m. Okay. And after that, again, you people requested from 2 hours before the session. So again, from afternoon 1:30 onwards, the servers will be powered on till evening 9:30. So you almost have 3.5 hours in the morning session, from afternoon 1:30 till 3:30. Again, from 5:30 till 9:30. 6:30, 7:30, 8:30, 9:30. Almost we have 7 hours available. So you can adjust and do the practice. All right.
Okay. Thank you, Mujib.
All right, guys. All right. Thank you so very much.
Mujib. Thank you.
Yes, we'll continue tomorrow. Tomorrow, important class, guys, because I'm dealing ESXi architecture and troubleshooting. Fine. All right. Those who want to continue with their labs, they can continue. The servers are on. Okay.